In today's lesson 9.2, solving quadratic equations by graphing, we're actually going to use Desmos for all of these activities. Now, if you recall in chapter 7, we solved quadratic equations by factoring, and we also solved them by graphing. So that's what we're going to take a look again here. Now, one of the things that we're going to want to do is write it here in standard form, and then find the x-intercepts, because the x-intercepts are what's going to make that set equal to 0. So if we take a look at our first example here, x squared plus 2x equals 8. Now it says solve by graphing. I'm going to show you two different things that happen here. So subtract 8 from both sides. So we have x squared plus 2x minus 8 equals 0. Now, when we graph it, we're just going to graph this part, not the equals zeros part. And I'm going to show you a few things that happen when you graph this and graph this. So go ahead and open up Desmos now. All right, so now that we're in Desmos, I'm going to go ahead and graph x squared plus 2x minus 8. So that's our graph here. And we can tell that our x equals -4 and x equals 2 are the solutions to this equation. Now, watch what happens when I have, so here's the graph. When I add equals 0, notice the graph changes. And the only thing it does is give me the x-intercepts here. So we've got x equals -4 and x equals 2. Now, watch what happens when I graph the original equation. I just get my x values here. So if you want to graph the equation, you need to make sure that it looks like this form. But honestly, to find the solutions, you can leave the equation as is. But for now, I would like to take a look at graphing. So here's our example 1. So it turns out we've got -4 and -2 as our solutions. All right, so that means we have x equals -4 and x equals 2, because that is where it is crossed at the y or the x-axis. Now, if we take a look at example 2 and 3, something a little different happens. So what I want to do again here is solve these, set them equal to 0. So I have x squared plus 4x plus 4 equals 0. Now we added 4 to both sides. Now jumping ahead to example 3, I'm going to do the same thing, but this time I'm going to add x squared to both sides. So I have x squared plus 4x plus 8. So let's go ahead and take a look at these in Desmos. Okay, so if I graph, here I have x squared plus 4x plus 4, and it crosses the x-axis just once here. It turns out it's our vertex, -2. So our solution here to example 2 is -2. Now let's take a look at example 3, where we have x squared plus 4x plus 8. Now, if you notice, it doesn't cross the x-axis, which means we don't have a solution here. So in this case, our answer is no real solutions because it does not cross the x-axis. Now watch what happens when I hit equals 0. Notice there's no graph, there's no solution, because the answer here is no real solutions because it never crosses the x-axis. All right, so our solution to example 2, as you recall when we graphed it, was 1 real solution, and x equals -2. Now here, it was no solution because, as you recall, our graph never crossed the x-axis. So our answer here is no real solutions. So how do we know how many solutions we're going to have? You have 2 real solutions when there are 2 x-intercepts. 1 real solution with 1 x intercept, and then no solution, no real solution when there are no x intercepts. Now, let's take a look at a real-life problem here. A soccer player kicks a soccer ball 2 feet above the ground with an initial vertical velocity of 60 feet per second. The function h equals negative 16 t squared plus 60t plus 2 represents the height h in feet of a soccer ball after t seconds. Find the height of the soccer ball after each second it is kicked. So we need to replace t with 0, 1, 2, 3, 4, and 5. Now I'm going to show you a cool little shortcut to save us some time. So I'm heading back to Desmos. I'm going to click on the Desmos here. Then I'm going to go to Math Tools, Scientific Calculator. Now what I'm going to do is enter in our equation. So negative 16, 0 squared plus 60 times 0 plus 2 and hit enter. So my answer here, well, it's covered up, is 2. So when t is 0, h is 2. Now the next one I need to do is 1. So what I'm going to do is highlight here. My answer there is 46. Now I'm going to do 2. Change my 1 to 2. I love Desmos. This thing rocks. And so that is 58. Next, I'm going to change it to 3. That answer is 38. That's interesting. My numbers are going down. I wonder what that means. Okay, so now I'm going to change it to 4. Be sure you're writing this down in your notes. And that's negative 14. That's interesting. Okay, so now let's take a look at 5. I assume this is also going to be a negative number. And negative 98. So let's bring it back to our class notes. So this formula shows us that the ball is going to go up and come back down. Now, can it really be negative feet here? Can I, if this is the ground, can I have a soccer ball go below the ground? I mean, I guess technically I could, but it's going to be a long shot if you hit it down a well. Okay. So now that we have our data here all filled in, let's go ahead and answer these questions. So use the results to estimate the height when the soccer ball is at 40 feet. So here, the ball is almost at, well, it's already above 40 feet. So we know it's going to be less than a second. So let's see, we're going to say about 1 second. And then here, it's also close to 40 feet because, as you recall, it's going to come up and back down. So here, we're also at about 1 second and about 3 seconds. So about minus 1 second, about plus 3 seconds. So now let's graph this and see what we end up with. All right, so let's take a look at our graph. So let's see, we have y equals negative 16x squared. I would avoid using t's and h's here. Sometimes Desmos doesn't quite understand the difference. So we'll go ahead and leave it at, and plus 2. So right now I've got some zeros here, but the question involved 40 feet above the ground. So this is seconds, and that this is our height. So we're going to have to find about 40, and where it crosses 40 is where we're going to find our answers. So we'll end up with about 1 and about 3 as well.